All right, Algebra 2 students, we're looking at the first lesson in Unit 6. Unit 6, we're learning about rational functions. And to introduce that, we're looking at the idea of inverse variation, which is a real-life thing that involves rational functions. So, taking a look at the info given to us, we know that if I was going to travel from Chicago to Minneapolis, maybe I play for the Bears and I have to drive there for some reason, the driving distance from Chicago to Minneapolis is about 400 miles. Now, if you ride up, excuse me, I-94 and your average speed is 40 miles an hour, think about how long it would take you to get there. Well, one thing that I would like you to consider is this equation that you learned at some point in either science or easy math class, D equals RT. Distance equals rate times time, okay? Now, in this scenario, I know the distance. Distance is fixed. It's 400 miles. That doesn't change. That's how far it is from Chicago to Minneapolis, no matter what. What can change is how fast you drive, your rate, okay? And if I want to figure out, well, how long does it take me to get somewhere? What's the time that it takes? I would take the distance that I'm traveling and I would divide it by the rate at which I am traveling. Now, look at this algebraically. If I take d equals r times t and I solve it for t, well, I'd be dividing both sides by r, and ta-da, you've got the expression that I wrote here, okay? Now, keep that in mind. For this situation, I'm going to write down a model that gives me the driving time for Chicago to Minneapolis for t as a function of r, okay, the average driving speed. So t is going to equal the fixed distance of 400 miles divided by the varying rate at which I can drive my vehicle. So, now, using that equation, let's imagine that we average 40 miles an hour. Well, plug in 40. 400 divided by 40 is going to be 10. So if we drive 40 miles an hour, that's our average. It's going to take us 10 hours to get from Chicago to Minneapolis. If I plug in 50 then, 400 divided by 50, well, that's 8. I can cut my time down to 8 hours. I can get up to 60 miles an hour for my average. Well, divide that. It's going to be 6.6 repeating. We'll go 6.6, put a bar over the top of it. Okay. And then if I were to somehow average 70 miles an hour, then I could do it in about 5.71. Okay. You can plug that in and check me out on that. So this would be a number of hours, okay, that it takes to get from one spot to the other. And this R, this would be miles per hour, how fast we're traveling, okay? And if I know the number of miles, I take the miles divided by the miles per hour, and I'm left with a number of hours, okay? This is an example of an inverse variation. It's an inverse variation because as I look at these two things, they are related to one another very closely, okay? How fast I drive determines how long it takes. The thing that makes this an inverse variation is that as I drive faster, okay, the faster I drive, the less time that it takes. So as R gets bigger, T gets smaller, okay? If I went the other way, if R got smaller, T got bigger, okay? So that's an example of, that's what inverse variation is. When one quantity goes up, the other goes down. They're inversely related to one another. If I was thinking of something that was a direct variation, okay, directly related, well, as one went up, the other would go up. That'd be direct variation, okay? So here's inverse variation. Here would be direct variation. Graphically, to show you what that looks like, if I've got, I'm going to decimals here. So y equals a times x, and a is a slider, okay? So as I hit play, a will change and my graph will change. Now, one thing that I want you, this is a linear equation. You learn about these in Algebra 1, okay? A is essentially the slope. Well, here right now I have a slope of 1, okay? Passes through the origin. Here's a slope of 1. Looks like a great equation. So, watch what happens to my curve as I hit play. So, it goes nuts. When it's negative, it flips over. Let's see, as it comes back to being positive, there we're going up from left to right. But the thing I want you to notice is if I were to zoom out here, as x gets bigger, okay, as I go this way, y gets bigger. So meaning as the input gets bigger, the output gets bigger. As the input gets bigger, negative, the output gets bigger, negative. That's a direct relationship, okay, direct variation. Now, when I take a constant and divide it by x instead of multiplying it by x, so here we go, y equals k over x. K is against some constant. Right now it's set to be 1, so this is essentially 1 over x. That's what it looks like. Okay, when I did my inverse variation equation for Chicago, Minneapolis, this constant was 400. Okay, and what I said is that as our rate got faster, our time went down. Okay, as our rate was slower, the time got bigger. That's what's happening to this curve. Check out this curve that I've got for k over x, in this case 1 over x. Well, as x gets bigger, the output gets smaller. Okay, and as x gets smaller, as it approaches 0, notice that the graph is going straight up. And in fact, there's a vertical asymptote there, which we'll learn about when we graph these rational function things. But again, as I play, watch it spread out a little bit. Okay, as k gets bigger, it spreads my graph out, but it still keeps its same shape. Now, if k is negative, it just sort of flips over the x-axis, but again, keeps its same sort of shape. A couple of branches, and we'll talk about what this graph is in a future lesson. So that's what inverse variation looks like. And again, the key is that instead of direct variation, where I'm taking x times a constant, I am taking a constant and dividing it by x. That's going to be inverse variation. If you were to take that equation, y equals k over x, and multiply both sides by x, you would see that k, my constant, is equal to x times y. Okay, two variables multiplied together gives me a constant value. Kind of like when I take, in order to find distance, I take rate times time. That was what we had before. Two variable things equaled 400 miles in the Chicago-Minneapolis example. So that would be taking a look at inverse and joint variation. Okay.